Chapter 1. The Bootstrap Paradox. Who made the map maker? Let's begin with a watch. Not just any watch, but an antique, a golden pocket watch, warm from years of use, ticking softly with a rhythm that feels familiar, almost familial. You find it in a dusty drawer in your grandfather's attic, nestled in velvet, engraved with initials you don't recognize, until one day you do. Because the initials are yours. Strange, yes? But here's where it gets stranger. You carry the watch through your life. It becomes a totem, a comfort, a curiosity. Eventually, as time has its way with all of us, you meet someone younger, someone who reminds you of yourself. Maybe a student, maybe your own child. You gift them the watch, and one day they tuck it away in an attic drawer. Full circle. Now let me ask you something unsettling. Where did the watch come from? It was never made. It was never bought, forged, or designed. It simply existed, looped in time, passed from hand to hand, never touching origin. A story without a first page. This is the Bootstrap Paradox, and it is as elegant as it is unnerving. A closed causal loop in which an object, a person, or even an idea becomes its own origin. It gets its name from the old phrase, pulling oneself up by one's bootstraps, which is, of course, impossible. But time doesn't seem to mind impossibilities. Imagine this. A scientist in the year 2300 discovers blueprints for a time machine. Tucked into the pages of an old notebook, dusty but brilliant. They build it. It works. Elated, they travel back to 2100 and pass the notebook to a younger version of themselves. That version grows up, studies the notes, and eventually becomes the scientist in 2030. So, who wrote the blueprints? The information exists in an eternal loop, unmoored from causality. No beginning, no end, just recurrence. It's a paradox because it violates the bedrock of logic, that every effect has a cause, that events unfurl in sequence, like dominoes. But in this loop, the dominoes circle back and topple their own origin. Douglas Hofstadter would see this not as a flaw, but as a strange loop, a concept he introduced in Gödel, Escher, Bach, a self-referential system in which levels of abstraction fold into each other. The observer becomes the observed. The symbol becomes the thing it represents. The snake eats its tail and calls it dinner. Time in this paradox is not linear. It is a Mobius strip, a loop with one side, one edge, and no clear starting point. And yet, paradoxically, it works. The math checks out. The loop can be consistent as long as everything inside it plays along. The universe permits it. But does it explain it? Let's push deeper. The Bootstrap Paradox isn't just about watches and notebooks. It can happen with people. Say a child is abandoned at an orphanage in 1980. They grow up, build a time machine, and after a life of curiosity and regret, travel back to 1970. There they meet a lonely woman. One thing leads to another, and the woman gives birth to a child in 1980. That child is them, no parents, no lineage, a self-born being, not science fiction, logical recursion. If this unsettles you, good. It should, because it asks something profound. What makes something real? Is it origin, causality, or is existence itself enough? If a watch ticks, a book is read, a person loves, must we care where they came from? Or is where and when an illusion? Now think about ideas. How many thoughts pass through your mind that you didn't invent? How many of your beliefs, your passions, your very sense of self are bootstrapped from culture, conversation, coincidence? Could it be that some ideas, like the watch, simply exist, without authorship? Here's a thought experiment. Suppose one day an artist wakes with a melody in their head. It feels ancient, like it's always been there. They write it down. Years later, another artist discovers the sheet music and performs it, unaware that it's a loop, because that artist inspired the first. An eternal song. No composer, just echo. What if you are the echo? What if your thoughts are part of a feedback loop that spans generations? What if your dreams, those wild, brilliant flashes of clarity, are whispers from a future that hasn't happened yet? The Bootstrap Paradox invites us to step out of linear time and into resonance. Not beginning and end, but rhythm. Not cause and effect, but recursion. And maybe this isn't a bug in their system, but the operating principle itself. Maybe life doesn't unfold like a novel. Maybe it loops like a canon. Themes return, characters echo, meanings deepen on each pass. So when you ask, where did the watch come from? Or, who wrote the blueprints? You're really asking, does it matter if truth is born, or if it simply circles back to find us? Perhaps the universe itself is a bootstrap, a loop without a craftsman. Not created, but recursive. Not explained, but experienced. And if that's true, then maybe we're not here to start something. Maybe we're here to remember something that's been circling the stars, waiting for us to open the drawer and find it ticking. Chapter 2. Schrödinger's cat, the feline that haunts. Possibility. Picture a box. It's not just any box, not a shoebox, not a treasure chest, not a metaphor for thinking outside. This is the box, a sealed, silent chamber, somewhere in the back of your mind. You don't know what's inside, and you can't open it. Not yet. Not until the time is right. Inside this box is a cat, though not in the way you're used to cats. This one is suspended in a state of limbo, entangled not in yarn, but in uncertainty. It is neither alive nor dead, but somehow both. Now let's build the box properly. We place a vial of poison in it, harmless on its own. But beside it, a tiny lump of radioactive material, unstable and unpredictable, waits in silence. Should it decay, at any random moment, a Geiger counter will click. That click will release a hammer. The hammer will shatter the vial. And the poison, well, we know what poison does. Here's the catch. The decay of that radioactive particle is a quantum event, completely governed by probability. It may happen in 1 hour, it may not. And until someone opens the box and checks, the system remains unresolved. According to the rules of quantum mechanics, until observed, the atom is in a superposition of two states, decayed and not decayed. That's not metaphor, that's physics. And since the fate of the cat depends on the atom, the cat too becomes superposed, both dead and alive, in a quantum blur of fur and fate. Now pause. Do you feel the disturbance? That rising unease as logic and reality begin to unbraid? This is where Erwin Schrödinger, the Austrian physicist who gave us this cat, wanted us to squirm. He introduced the paradox not to embrace it, but to critique it. He thought it absurd that quantum rules could apply to everyday things like cats, or people, or you. And yet, here we are. In the classical world, things are either this or that. You are awake or asleep. Your glass is full or empty. The cat is alive or dead. But quantum mechanics refuses to pick sides. It says, until measured, all outcomes exist at once, not as alternatives, but as a tangled mass of probabilities. But wait, let's back up. Who's measuring what and when? In this bizarre play, the observer plays the starring role. Only when someone, a conscious entity, a mind, opens the box does the wave function collapse. Until then, the cat is both dead and alive. And neither. It exists in a probabilistic fog of maybe and maybe not. This raises a frightening possibility. Reality does not exist in a definite form until it is observed. The universe is not a machine humming in the background, but a stage that activates only when watched. Here comes the Hofstadter twist. What if the observer is also inside a box? What if you, reading this, are the cat, unaware of the observation that defines you? What if consciousness itself is a recursive echo chamber, where each thought measures another, collapsing superpositions of mood, belief, and identity every second? And here's another wrinkle: the many worlds interpretation. Some physicists believe that every possible outcome actually happens in parallel universes. When the box is opened, the universe splits. In one, the cat lives. In the other, it dies. Two timelines diverge, each as real as the other. One cat purring in a sunbeam, another still and silent. This would mean that every decision, every measurement, births a new reality. Not just in physics, but in life. You turn left instead of right. You say yes instead of no. You stay when you should have run. Somewhere, a version of you made a different choice. Somewhere, a different you opens the box. The cat, then, is not just a feline. It is a symbol, a mirror. It asks, what parts of you remain unresolved? What parts of your identity are still in superposition? Are you the brave version of yourself, the cowardly one, the kind one, the selfish one? Or are you all of them, and none, until a moment comes that collapses the wave function of your character? In a way, Schrödinger's cat is always with us. Every unread email, every unopened letter, every diagnosis still sealed in an envelope is a quantum box. Until we look, the outcome remains a tangle of hope and dread. And when we do look, we are changed, because the act of opening the box doesn't just collapse the cat's fate, it collapses ours. And now we must ask, is this paradox a glitch in reality or a blueprint? Is the universe fundamentally probabilistic, a grand experiment of superposed truths? Or is this a metaphor for the human experience itself? Our hesitations, our contradictions, our longing to know, and our fear of knowing. In this sense, the cat is immortal, not in body, but in idea. It lives on as the patron saint of ambiguity, the embodiment of maybe. And perhaps that's the closest we ever come to truth. So the next time you hesitate to open the box, ask yourself, not, what if the cat is dead or alive? But rather, what if the cat is you? Waiting for the moment reality chooses. Or, the moment you choose reality. Chapter 3. The EPR Paradox. Spooky action at a distance. Let's begin with a single thread. Not a metaphorical thread, though we'll get to those, but a literal, shimmering strand of quantum silk. It stretches across space, invisible yet unbroken. On one end, a particle. On the other, its twin. Born together, entangled. Two hearts beating in quantum rhythm. Now snap your fingers. A world away, miles, light years perhaps. One of those particles is measured. Instantly, the other responds. No delay, no warning. Just a flash of knowledge shared faster than light could ever hope to travel. As if the two ends of that thread were still one. This is not science fiction. This is entanglement. This is the EPR paradox. Named after Albert Einstein, Boris Podolsky, and Nathan Rosen, this paradox was meant to expose a crack, a flaw, in quantum mechanics. In 1935, the trio published a paper arguing that quantum theory, elegant though it was, must be incomplete. Why? Because it allowed for this kind of spooky action at a distance. Einstein loathed it. Nature, he believed, doesn't play dice, and she certainly doesn't send telegrams faster than light. Let's rewind to understand their argument. Suppose you create a pair of particles in a shared quantum state. Let's say they're electrons, spinning oppositely so that the total spin is zero. A kind of balance in the quantum seesaw. These two particles fly apart in opposite directions, light years apart if you wish. They remain entangled, their fates intertwined. Now if you measure the spin of one, say it's up, then instantly, without even touching it, you know the other is down. The problem? That knowing happens faster than the speed of light. Instantaneously. No time for information to travel, no whisper of a signal, as if space were irrelevant, as if distance had been deleted. Einstein called it spukhafte Fernwirkung, spooky action at a distance. He believed there must be hidden variables, unseen instructions encoded in each particle from the start, like identical twins raised apart who still crave the same coffee, a kind of cosmic coincidence. But quantum mechanics said, no, there are no hidden variables. The particles don't know what they'll be until they are observed, and when they are, one decides and the other follows, across space, outside time. Years later, physicist John Bell formalized this mystery. He proposed an inequality, Bell's inequality, that could distinguish between hidden variables and true quantum entanglement. The tests were done. The results were clear. Entanglement was real. Spooky action wasn't just a bug. It was a feature. Now imagine what this means. If two particles can remain linked across space, responding to each other without a signal, then space itself may be an illusion. The idea of separateness, of here and there, begins to crumble. Distance is not absolute. It's contextual. It's a story we tell ourselves in the absence of deeper connection. Hofstadter might pause here and ask, what if we too are entangled? Not in the atomic sense, though who's to say, but in the human one. Haven't you felt it? That instant tug in your heart when someone you love feels pain? That synchronicity that defies logic, where you dream of someone the night before they call? What if connection is not a matter of proximity, but of resonance? Let me spin you a story. Two twins are born. As infants, they lie in the same crib, breathe the same air, dream the same dreams. Eventually, life separates them. One moves to Paris, the other to Kyoto. They live separate lives, eat different foods, speak different languages. And yet, one night, one twin wakes from a deep sleep with a scream. At the precise moment, the other is in a car crash. No phone call, no warning, just knowing. Coincidence or quantum echo? Entanglement suggests a universe where connection is not built, but remembered, where certain things are never truly apart, just folded differently in the fabric of existence. And now, the Hofstadterian recursion. What if the universe itself is entangled with itself? What if every atom, every thought, every poem and pebble and paradox is part of a grand self-referential loop? What if consciousness, yours and mine, is not local to our skulls, but smeared across space, reflected in mirrors of awareness we haven't yet discovered? Maybe this is why paradoxes exist, not as errors in thought, but as signposts, fractals, winks from the universe that reality is more like a strange loop than a straight line. In this view, the EPR paradox becomes not a contradiction, but a compass. It points away from locality toward unity, away from distance toward entanglement. It tells us the world is not made of separate things, but of relationships, threads, woven into a single tapestry. So the next time you feel alone, remember this. Somewhere, perhaps light years away, something may be echoing your state. Not because it's watching, but because it is you, folded elsewhere. Entanglement is not a trick of physics. It is the ghost in the machine, the whisper in the silence, the proof that even in the cold vacuum of quantum space, nothing, absolutely nothing, is ever truly alone. Chapter 4. The Black Hole. Information Paradox. When memory vanishes. Let's begin with a funeral. Not a somber one with flowers and hushed voices, but the funeral of a truth, a hard, scientific truth we once held sacred, that information cannot be destroyed. Physics stood tall on this idea for centuries. From Newton's deterministic tick-tock to quantum theory's probabilistic dance, one rule reigned supreme, that the universe always remembers. Until, one day, we discovered a place where memory goes to die. We call it a black hole. Imagine this. A star dies in a supernova, collapsing under its own weight. Its core compresses, its mass folds in upon itself, and space-time warps beyond comprehension. The result is not an object. It is a boundary, a one-way door. The event horizon. Cross it and you never return. Not even light escapes. Now, drop something into it. A book, a photograph, a person, a planet. Watch it fall, slower and slower from your perspective, red-shifting into invisibility until it vanishes altogether, swallowed by the abyss. And here comes the paradox. According to Einstein's theory of general relativity, once something crosses the event horizon, it's gone. Lost to the singularity, erased, but quantum mechanics violently disagrees. It demands that information, the physical state of a system, can never be truly destroyed. It can scramble, it can hide, but it must remain, somewhere, somehow. So what happens to the information about what fell in? Stephen Hawking, in the 1970s, rocked the scientific world with a devastating answer. It disappears. He showed that black holes emit a faint glow, now called Hawking radiation, as quantum pairs of particles pop into existence at the edge. One falls in. The other escapes. Over immense time, the black hole loses mass. It shrinks, it fades, it evaporates. And when it's gone, the information is gone too. Gone forever. This broke the universe. Hawking's result implied that physics isn't reversible, that you could burn the encyclopedia of existence, and no smoke, no ash, no echo of its contents would remain. That cause and effect could be decoupled. That reality could forget. It triggered a crisis. An epistemological earthquake. The laws of quantum mechanics and the laws of gravity, two towering pillars of modern science, stood face to face, and one of them had to blink. But here's the thing. Hofstadter would not see this as merely a contradiction between equations. He'd see it as a metaphor, a loop, a question about memory, identity, and loss. What is information, after all? What does it mean to be remembered, not just by the cosmos, but by ourselves? Let's go deeper. Some physicists now argue that black holes do preserve information, but not in ways we understand. One theory suggests that the event horizon acts like a kind of hologram, storing the information on its surface in scrambled form. This is the holographic principle, the idea that everything that falls in is somehow encoded on the skin of the whole, like a cosmic tattoo. Others propose that information leaks out through Hawking radiation, not randomly, but subtly encoded in its pattern, like an enormous quantum Sudoku puzzle slowly solving itself over eons. Still others say we're looking at it all wrong, that black holes aren't just endpoints, but portals in a deeper geometry, that they tunnel into other universes, that the information isn't lost, it's just elsewhere. Let's turn inward now. What do we do with our own black holes? Those memories we bury, the dreams we lose, the people we no longer remember. Are they gone or encoded in us in ways we can't yet decipher? Think of a forgotten song that suddenly returns. Melody, lyrics, emotions intact. Because a smell, a color, a passing phrase awakened it. Was that memory lost? Or just compressed, like information near an event horizon, waiting for its own Hawking radiation to set it free? Perhaps we are holographic beings, our identities projected from a deeper level, our pasts woven into the boundaries of consciousness. Perhaps you are the black hole, vast, unknowable, dense with secrets, and your life is the radiation, flickering, mysterious, fading across the universe. Now let's flip the frame again, Hofstadter style. What if black holes are not where information goes to die, but where it goes to transform? A caterpillar does not vanish in the cocoon, it reconfigures. Maybe black holes are nature's chrysalis, where particles, identities, and realities are remixed and reborn. What if the reason we cannot recover the information is not because it is gone, but because it has become something else? This is the essence of the paradox. Not loss, but transformation. Not oblivion, but recursion. Not a dead end, but a loop. A strange, sublime loop that swallows truth and spits out mystery. So the next time you look at the stars and wonder what happens when things disappear, remember, in the heart of the black hole, the universe may be whispering, not goodbye, but wait. And maybe, just maybe, it's waiting for you to remember what you never truly forgot. Chapter 5. The Quantum Zeno Effect. When watching becomes a cage. Let me tell you a story about a candle, a monk, and a question that the universe has yet to answer. The candle sat in a dark room. Nothing fancy, just a simple taper of wax with a stubborn little flame, quietly doing its job. The monk, a curious fellow with a peculiar habit, was obsessed with the flame. Every second, without fail, he would peer into the room and check. Is it still lit? Every time he looked, the flame sputtered but held. Another glance, and again it flickered but did not falter. Minutes turned to hours. Days passed. The monk grew tired but never ceased. The flame, oddly enough, never went out. Not once, as if it feared disappearing under his watchful gaze. Now, this is not just a monk's tale. It is a parable whispered by quantum mechanics. It is the quantum Zeno effect, and like many things in the quantum world, it laughs in the face of intuition. You see, in the everyday world, the classical world, observation is passive. You can watch a clock tick, a flower bloom, a heart break, and your watching does nothing to halt the unfolding. But the quantum world is a trickster. It changes when observed. At the smallest scales, particles do not exist in any one place or state until you look. They are smeared across probabilities, suspended in superpositions. Measurement collapses this ambiguity into a definite outcome. But here's the twist. Observe too often, and the collapse happens again and again, not allowing the system to evolve. Like a child constantly pressing pause on a movie, the story never advances. This idea is an echo, a quantum riff, on an ancient paradox. Zeno of Elea, the Greek philosopher, once argued that motion was impossible. If every journey is divisible into infinite halves, how could we ever complete it? His logic was sound, but his conclusion felt absurd. Now, in the 20th century, quantum physicists would rediscover Zeno's ghost in their equations. Let's make it concrete. Suppose we have an unstable atom. It wants to decay, to shift from one energy state to another. If left alone, it will do just that. But if you check on it frequently, it resists, as if your very concern imbues it with stability, as if the act of questioning its fate holds it hostage to its current form. What's happening here? In essence, every observation resets the clock. The atom's probability of decaying starts over from zero. The wave function, that enigmatic, ghostly equation describing its state, collapses with each look, only to swell up again afterward. Collapse, swell, collapse, swell. And if you repeat the cycle fast enough, you suspend its transformation. It becomes stuck in an eternal now. Time, it seems, can be made to stutter, not by magic, but by attention. Now imagine the implications. The mere act of watching can preserve the present, delay the future. What kind of world are we living in, where observation becomes a form of control, or perhaps a prison? Are we, ourselves, victims of the Zeno effect? How many times do we peer into the mirror of our own minds, checking and rechecking our thoughts, freezing them into place with obsessive self-awareness? How often do we stall our progress by refusing to let go, to trust the process, to allow uncertainty its rightful role? The monk, remember, he believed he was protecting the flame, but in truth, he had locked it in a cage of attention. It could not grow nor fade. It was not alive nor dead, just suspended. And so we arrive at a deeper question, not scientific, but existential. If the universe responds to observation, then who are we in this strange game of mirrors? The watchers, the watched, or both? Perhaps the most Hofstadterian twist of all is this. In studying the quantum Zeno effect, we see not just a paradox of time and decay, but a metaphor for consciousness itself. We are recursive beings, minds thinking about minds thinking about minds. Every self-reflection, every act of inner scrutiny might be its own kind of measurement. Do we stall our own evolution with the relentless pulse of introspection? Or, more unsettling, is reality itself a loop of self-measurement? A Mobius strip where the observer and the observed endlessly chase each other across the edge of certainty. This is the beauty of paradox. It's not just a riddle, it's a mirror. It's not just something to solve, it's something to feel. So next time you stare into the heart of a flame, remember, it might be staring back, and maybe, just maybe, it's waiting for you to blink, so it can finally begin to burn. Chapter 6. The Grandfather Paradox. The loop that breaks itself. Let's begin with a time machine. Not the sleek chrome pod of Hollywood fame, not a glowing DeLorean or a spinning phone booth. No, this one is quiet, almost forgettable. A dusty elevator in a crumbling library, a hidden dial beneath a loose floorboard, a whisper in your ear that says, you could go back, you could fix it. You step inside. Your destination? The year 1955. The mission? Simple. Prevent a terrible future. Prevent your future. Stop a man, an ordinary man. Maybe he's kind, maybe he's cruel, but what matters is this. He's your grandfather, and you've come to kill him, because if you succeed, if you stop him before he meets your grandmother, then your parent is never born, and neither are you, which means you couldn't have traveled back in time to commit the act in the first place, which means your grandfather wasn't killed, which means you were born, which means you did travel back, and so the paradox begins. This is the grandfather paradox, a time loop with a broken neck, a riddle that eats its own cause, a contradiction wrapped in cause and effect, where action unravels origin. At first glance, it's a logical puzzle, a thought experiment. But as with all deep paradoxes, the real discomfort lies beneath the surface. It challenges not just physics, but identity. Because what is the self, if not a thread spun from memory and biology and time? If you cut the thread mid-spin, what remains? Some physicists try to untangle the knot with rules. They say time protects itself. That reality won't let you create contradictions. This is called the Novikov self-consistency principle. The idea that you can travel back, but only as an actor in a script already written. You can light the match, but you can't stop the fire you were born from. Others suggest a different solution, a more radical one. Every decision, every change, every time-traveling assassin creates a new timeline. A split. A fork in the universal road. In this view, killing your grandfather doesn't erase you. It births a new universe where you never existed. Meanwhile, the original version of you still lingers in the timeline you came from, untouched by paradox. But if that's true, then what are you? A traveler without a home? A version cut loose from its origin? And what if the very act of trying to undo your own creation is the most human thing of all? Because, let's face it, we've all wanted to go back. Back to before the mistake, before the lie, before the choice that pulled the thread loose. We dream of edits, rewrites, we whisper, if only, like a prayer. The grandfather paradox is not just a sci-fi riddle, it's a mirror. It asks, what would you change if you could? And more dangerously, should you? Because every action you'd erase is part of the path that led you here. Every wound, every regret, every impossible loss, stitched into the fabric of your becoming. To undo it is to undo yourself. But let's wander further. Suppose you don't kill him. Suppose you merely nudge, drop a letter in a cafe, sabotage a date, distract him at the moment of meeting. The paradox still loops, quieter but no less deadly. The moment your intervention prevents your own conception, the gears grind. You disappear. The machine coughs. The loop closes with nothing inside. Here's a thought. Maybe paradoxes aren't errors in logic, but proof of limits. Boundary markers at the edge of knowability. Places where cause and effect fold too tightly to distinguish, where the pen writes backward through the story. And maybe time isn't a line, but a rope, frayed at the ends, knotted in the middle and always tightening on itself. There's a deeper terror here, though. Not that we might erase ourselves, but that we might fail to. That no matter how far back we go, no matter how much we tinker, some things, some heartbreaks, some traumas, are stitched into the pattern too deeply to be pulled without tearing the whole. And maybe that's the final twist. The paradox isn't about the grandfather. It's about you, your guilt, your longing, your need to control the past. But time doesn't bend to need. It doesn't heal when rewound. It simply is So what do we do with that? We move forward, one impossible moment at a time, carrying the ghosts of choices we didn't get to unmake. And maybe that's what makes us real, not the power to rewrite our story, but the courage to keep turning pages. Because the past doesn't vanish. It echoes, and somewhere a watch ticks in reverse. Chapter 7. The Fermi Paradox. The silence that shouldn't exist. There's a rumor the stars are keeping. It isn't loud. It doesn't shout through nebulae or blaze across wormholes. It hums, softly, beneath everything we think we know. It vibrates in the background radiation, in the static between planets, in the quiet unease that grows when you look up at the night sky and realize no one's waving back. This is the Fermi Paradox. The contradiction between the high probability of extraterrestrial life and the stunning, total silence of the cosmos. Let's start with the math. There are around 100 billion stars in our galaxy. Many, maybe most, have planets. Some of those planets are like Earth, rocky, temperate, wet. Some are older than our sun, meaning life there could have had a head start of millions or even billions of years. Now consider this. If intelligent civilizations emerged, even rarely, and developed technology even slightly more advanced than ours, they would have had the time, and potentially the desire, to colonize the galaxy, to send signals, ships, probes, something. But instead, silence, no messages, no artifacts, no buzzing swarm of von Neumann probes reproducing across the stars. Just quiet. So physicist Enrico Fermi, over lunch in 1950, asked the question that became a paradox. Where is everybody? Let's dwell there. In that question. Because behind it hides an entire cathedral of doubt. Some suggest we're the first, that life is rare, and intelligence even rarer. That we are the newborns of the universe, fumbling in the dark before anyone else has had time to strike a match. Others say we're the last, that civilizations emerge, burn brightly, and then vanish, that the galaxy is littered with silent tombs, dead worlds, civilizations that reached for the stars only to fall into themselves. And then there's the possibility we're not rare or alone, but simply unnoticed, or worse, ignored. Maybe the others are watching, and they've chosen silence. Let's spiral deeper. Perhaps the silence is protective, a kind of galactic quarantine designed to shield young, reckless species, like us, from contact until we've matured, or perhaps to shield the others from us. Think of a tiger behind glass. The glass isn't there for the tiger's safety. Or consider the dark forest hypothesis, a chilling metaphor. In a dark forest, every creature must remain silent, because every noise is a risk. Every signal could betray your location to a predator. So you stay quiet, you hide, you kill if needed. Maybe the cosmos is full of life, and everyone's whispering, and we're the ones shouting into the dark. Now pause, breathe, because the most haunting possibility is not that we are first or last or being watched, but that we are alone, utterly, that life is a fluke, that consciousness is a glitch, that the universe is indifferent, not hostile, not protective, but vast and empty, that the silence isn't hiding an answer. It is the answer. But let's not end there. Let's twist inward. Because the Fermi Paradox isn't just a question about aliens. It's a mirror. It asks, what does it mean to be intelligent and alone? What kind of species builds radios, sends messages into the void, and waits, decade after decade, for a voice that never comes? Maybe the paradox is not out there. Maybe it's us. Our need to connect. Our inability to accept a stage without a second act. Our refusal to believe that the grand theatre of the universe was built for a single monologue. And yet we keep speaking. We launch golden records. We beam songs into space. We listen. We watch. We imagine. Perhaps that's the answer hiding inside the question. Maybe the paradox isn't meant to be solved. Maybe it's meant to inspire, to haunt us into becoming worthy of a reply, or to teach us how to fill the silence with our own meaning. And maybe one day, when we least expect it, when we've stopped searching, something will blink back, not a transmission, not a spacecraft, just acknowledgement, a flicker in the static, a whisper in the silence. There you are. Chapter 8. The Twin Paradox. A clock, a rocket, a life torn in two. Once upon a time, there were two twins, identical in every way. Same DNA, same laugh, same freckle just beneath the left eye. As children, they built paper rockets and argued over who would go to space first. As teenagers, they traced stars with their fingers and made promises they thought time couldn't touch. And then, one left. Let's say it was the elder by minutes, Twin A, who became the astronaut. They boarded a spacecraft designed to travel at near light speed, not to flee, not to escape, but to explore, to chase the edge of time. The other, Twin B, stayed on Earth. They watched the launch. They counted the days. They grew older. Twin A? They raced across the cosmos at velocities Einstein warned us would stretch the fabric of time. Their clock slowed. Their body aged differently. This is the twin paradox. It's not really a paradox in the mathematical sense. Relativity explains it. But it feels like a paradox because it defies everything we know about shared experience. It tells us that time is not universal, that motion warps reality, that the simple act of moving fast can make two lives, once entwined, slip out of sync. From the perspective of Twin A, only a few years pass. From the perspective of Twin B, decades. So when the spaceship returns, and it does return, one twin is aged, wrinkled, weathered, world-worn. The other, barely changed. A moment passes between them, then 1,000 more. Because now they are no longer twins, not in time. One has watched birthdays stack like autumn leaves. The other has watched stars pass in silence, feeling only the engine's hum. They embrace. But the hug feels unbalanced, like one of them is still dreaming while the other has already woken up. How can two people, once so close, live in such different presence? This is the gift and curse of special relativity. At speeds near the speed of light, time dilates. A moving clock ticks slower relative to a stationary one. But this isn't just theory. It's been tested. Astronauts on the International Space Station age fractions of a second slower than we do. Not much, yet. But scale it up, and time becomes negotiable. And so we return to the paradox. Not one of numbers, but of experience. Because how do we reconcile a universe where time itself is not consistent? Where now means different things depending on where you are and how fast you're moving. We think of time as a river, but it's not. It's an ocean, flowing in eddies and tides, warping around mass and speed, slipping between our fingers the moment we try to hold it. And here's the deeper truth. We all live in our own time. You are aging at a different rate than the person next to you. Infinitesimally, perhaps. But still, each of us carries a unique clock, ticked forward by velocity, by gravity, by motion through space. Even standing still, we drift apart. But the paradox becomes even more intimate when we realize it's not just about physics. It's about choice. Twin A chose the stars, Twin B chose home, and both lost something in the process. One missed weddings, funerals, rainy Sundays. The other missed silence, awe, and the glow of distant suns. So maybe the real paradox is this. No matter which path we choose, we always lose time we didn't know we were spending. But here's the loop. Though Twin A returns younger, time hasn't spared them. The cost is paid not in wrinkles, but in moments never lived. The years their twin spent laughing, grieving, growing, gone. The shared path forked forever. And that is the paradox that haunts us all. We cannot move through life without motion, and motion bends time. Every decision, every step forward, warps the trajectory of experience. You can't freeze a moment. You can only choose which ones you'll live, and which ones you'll leave behind. So the question becomes, which time are you running toward? And who, or what, will you find when you get there? Chapter 9. Olbers Paradox. Why is the night sky dark? Look up. On a clear night, away from the hum of cities and the haze of electricity, the stars appear, scattered diamonds on a black velvet sky. Some shimmer softly, some blaze, but in between, darkness. Vast, endless darkness. And that is the problem. Because the night sky shouldn't be dark, this is Olbers' paradox, named after the 19th century German astronomer Heinrich Wilhelm Olbers, though versions of the riddle go back centuries. It seems simple enough. If the universe is infinite, filled with stars scattered uniformly through space, then every line of sight, in every direction, should eventually end at a star. No matter where you look, your gaze should land on a glowing surface. The sky should be ablaze, brighter than day. But it's not. Instead, we live under a canopy of blackness pierced by points of light, stars not as background, but as exceptions to the void. So, where is all the light? Let's build the logic step by step. Assume the universe is infinite, static and eternal. Assume that stars are evenly distributed throughout this universe. Then, no matter where you look, you should see a star. Just as in a dense forest, every sightline eventually ends at a tree. Therefore, the sky should glow, continuously, completely, without darkness. But it doesn't. And that contradiction, that gap between what should be and what is, opens the door to one of the most profound revelations in cosmology. Because this paradox isn't just a quirk, it's a diagnosis, a sign that our assumptions about the universe are wrong. First came the realization, the universe is not eternal. It had a beginning, a birth, roughly 13.8 billion years ago, in a singularity we now call the Big Bang. Second, the universe is not static. It is expanding. Galaxies are moving away from each other, stretching space like dough in the hands of time. As they recede, the light they emit is redshifted, stretched to longer wavelengths, sometimes beyond the visible spectrum. And third, light has a speed limit. The light from stars beyond a certain distance, beyond our cosmic horizon, simply hasn't had time to reach us yet. So, the darkness we see isn't emptiness. It's youth. It's a veil drawn across the sky by the limits of light and time. The stars are out there, maybe, but their stories haven't arrived yet. But that's just the physical side of the paradox. There's a deeper version. Because the night sky is not just dark, it is lonely. Every evening, the paradox replays above us, a quiet, cosmic contradiction that doubles as a question. Why do we find meaning in the absence of light? Because maybe the darkness isn't empty at all. Maybe it's potential. Each patch of black is a story still waiting to be told. A photon en route, a galaxy just beyond reach, a moment of silence before a cosmic revelation. And more than that, the darkness is what lets the stars shine. If the sky were ablaze in every direction, we wouldn't see the points of light. We wouldn't notice the shimmer of the distant suns. The contrast, the absence, is what gives the stars their shape, their grace, their significance. And isn't that always the case? In life, as in the cosmos, meaning emerges in the margins, in the space between, in the things not said, the days not lit, the paths not taken. If everything were illuminated, nothing would stand out. So the paradox becomes a kind of poetry. We expect fullness, and we are given fragments. We crave answers and are met with silence. But in that silence, that starlit silence, we discover something we didn't know we were looking for. Perspective. The darkness tells us we are small, that we are temporary, but it also whispers that we are awake enough to ask, to wonder, to look. And maybe that is the point. Maybe the universe keeps some things hidden, not to frustrate us, but to teach us how to search. So the next time you look up and find only blackness, don't turn away. Understand, it's not a mistake. It's a message. The stars will come. They always do. Chapter 10. The Monty Hall Problem. When switching changes everything, you're on a game show. Bright lights, nervous sweat, applause that echoes like a storm. You've made it to the final round, and the host, charming, mischievous, and always just a little too enthusiastic, stands beside 3 doors. Behind one door is a brand new car. Behind the other 2, goats. Not metaphorical goats, not philosophical goats, literal, bleating, hay-chewing goats. The host smiles and asks the question that will spiral your mind into a knot. Which door do you choose? You pause, think. Pick door number 1. Now the host, let's call him Monty, does something curious. He doesn't open your door. Instead, he opens another door. Door number 3. Behind it, a goat, chewing lazily, entirely uninterested in the drama. Monty turns to you. You can stick with door number 1, he says, or switch to door number 2. One last choice. Simple, right? But this is where the paradox begins. Because every fiber of your being wants to say, it doesn't matter. It's 50-50 now. 2 doors, 1 prize, equal odds, but that's wrong. If you want to win, really win, you should switch. Every time. Statistically, switching gives you a 2/3 chance of winning the car. Sticking with your original choice? Only 1/3. Let's walk the loop. When you first choose, you have a 1 in 3 chance of picking the car, which means, here's the twist, you have a 2 in 3 chance of picking a goat. Monty, who knows what's behind the doors, always reveals a goat from the remaining 2. Always. So if your initial choice was a goat, which it is 2/3 of the time, then the car must be behind the other unopened door. And switching wins. But the brain hates this. It feels wrong. It feels like a trick. Because humans don't think in probabilities. We think in stories, in fairness, in symmetry. We flatten complexity into instinct. And instinct says, it's even now. Flip a coin. But this is not a coin flip. It's a recursive trap. And now the paradox unfolds in full. Because even when the math is explained, even when the proof is shown, most people still refuse to switch. Even Nobel laureates have stumbled over it, even computer scientists, even game theorists. The Monty Hall problem is a paradox, not because the logic is broken, but because we are. It exposes the gap between reasoning and reality, the chasm between data and decision. It shows us that our minds are pattern machines, built for survival, not truth. But here's the haunting twist. This isn't just a game show. This is life. We're all standing in front of doors, jobs, relationships, beliefs, identities. We make choices. Then the universe, like Monty, reveals something. Not the full answer, but a partial truth. A goat behind door number 3. We're given a second chance. But we rarely switch. We cling to our original choices, out of fear, out of pride, out of inertia. We think, I've come this far, I might as well stay. Even when logic whispers, there's a better option. The Monty Hall problem is not just about probability, it's about change. It asks, when given new information, are you willing to pivot, to risk being wrong, to trade familiarity for uncertainty in hopes of a better outcome? Because the truth, the cruel, liberating truth, is that the odds are not always what they seem. And sometimes the smartest move is to walk away from the door you've been defending. So the next time you're faced with a choice, a job, a belief, a path, and the world reveals a little more than it did before, don't just trust your gut. Trust the numbers. Trust the loop. Trust the goat. And switch. Chapter 11. The Observer Effect. When seeing changes being, imagine a curtain. Behind it, something flickers. Not quite there, not quite gone. It dances between states, between possibilities. It might be a wave, smooth and infinite, or a particle, sharp and defined. It might be spinning clockwise or counterclockwise, or neither. Until you look. And in that moment, the curtain drops. The performance collapses into a single, irreversible act. What was once a sea of maybe has become a singular yes. You didn't just witness reality, you made it. This is the observer effect. It's one of the most unsettling truths buried in the quantum fabric of our universe. The very act of measurement changes the system being measured. Not in the sense that a thermometer disrupts a flame, or a scale shifts slightly under your feet. Number. In quantum mechanics, measurement doesn't merely disturb the system, it defines it. Before measurement, a particle exists in a superposition, a blend of all possible states. But when you observe it, that fog of potential collapses into something definite. It becomes one thing, and not the others. The particle, in a very real sense, decides what it is because you asked. Let's step into the famous double-slit experiment. Fire electrons, one at a time, at a barrier with 2 slits. Beyond the barrier is a screen that records where they land. Do this long enough, and you'll get an interference pattern, a series of light and dark bands, as if the electrons were waves interfering with themselves, which makes no sense. These particles were sent through one by one. How can they interfere with themselves unless they were in multiple places at once? Unless they were, in some ghostly way, everywhere. But now place a detector at the slits to see which one each electron passes through. You want to know. And suddenly, the interference pattern vanishes. The electrons behave like little bullets now, choosing one slit or the other. The act of observation, of wanting to know, has erased the wave behavior. You've traded possibility for certainty. You've collapsed the cloud into a point. And this isn't just a metaphor, it's a measurable change. It's reproducible, reliable, and deeply disturbing, because it means the universe behaves differently depending on whether or not you're watching. It raises the question, is the world really out there, humming away on its own? Or does it only crystallize when conscious eyes fall upon it? Now take this a step further. If particles don't exist in definite states until observed, what does that mean for the moon when no one's looking? What about your childhood home, your dreams? Do they flicker in and out of being when no one remembers them? Some interpretations suggest that consciousness itself plays a role in collapsing the wave function, that the act of awareness is a kind of cosmic switch, flipping reality from fog into form. This view, while controversial, isn't easily dismissed, because if observation defines being, and if humans are the only observers we know of, then what role do we play in the existence of the cosmos? Are we passive witnesses, or are we co-authors? But let's step away from physics for a moment and look inward, because the observer effect isn't just in labs and lasers, it's in us, in our behavior, our psychology, our relationships. We change when we know we're being seen. Put someone under a spotlight, and they alter their posture, their voice, their values, not out of deceit, but out of instinct. To be watched is to be shaped. And it goes deeper still, because we observe ourselves constantly. An inner monologue, a gaze turned inward. We measure our thoughts, judge our own feelings, and each act of self-observation collapses a wave of possible selves. You were angry, but then you noticed your anger, and now you're calm. You were certain, but then you reflected, and now you doubt. Every layer of awareness changes the layer beneath it. A mind watching itself in an infinite hall of mirrors, bending shape with every glance. And maybe, just maybe, this is what consciousness is. A strange loop of observation, a recursive tangle of awareness folding in on itself. And in that loop, the self is born. Not as a static entity, but as a process, a collapse, a performance. So what happens if no one's watching? If nothing is measured? If no gaze falls upon a system, does it exist at all? In the quantum world, that question doesn't have an answer. Or perhaps it has too many. Because maybe the universe is like that stage behind the curtain, waiting to be seen, aching to collapse into form. Or maybe it's the curtain itself, choosing when to fall. Or maybe, most unsettling of all, we are the curtain, the ones dropping into reality the moment we open our eyes and ask, what is this? The observer effect is not just a scientific phenomenon. It's a parable, a story about presence. It reminds us that attention is a force, that to look at something is to change it, that to be looked at is to become something different, and that, in a universe built on uncertainty, awareness itself might be the most powerful action of all. So the next time you glance at a stranger, and they smile differently because of it, the next time you hear your own voice and cringe because it feels foreign, the next time you realize you've become someone new just by noticing who you were, remember, the act of seeing is never neutral. It is always creation. Chapter 12. The Information Paradox in Quantum Mechanics, where memory meets the void picture. A letter, a personal one, ink smudged by fingers, folded twice, written from the heart. Now imagine dropping it into a fire. The paper blackens, curls, smoke rises, ash falls like snow. The words disappear. You watch the flame and tell yourself it's gone. But the universe disagrees, because according to the laws of quantum mechanics, information cannot be destroyed. It can be scrambled, dispersed, folded into noise, but it must remain. Somewhere. Somehow. The equation that governed the letter's atoms, the structure of its ink, the pressure of each pen stroke, all of it, in theory, is preserved. The cosmos doesn't forget. Not even for a moment. But then came the black hole, a monstrous, elegant contradiction, a place where gravity becomes so intense, so irresistible that even light cannot escape. A singularity wrapped in an event horizon, a boundary from which no information, no signal, no story can return. It's not just a trap, it's a severance. Drop anything in, a particle, a poem, a person, and it is cut off from the observable universe, as if it never was. At first, that wasn't the problem. Black holes were strange, but tolerable, anomalies on the edge of understanding, until Stephen Hawking, in the 1970s, changed everything. He showed that black holes aren't entirely black. They radiate. Quantum effects at the edge of the event horizon cause particles to escape, slowly draining the black hole of mass. This Hawking radiation means that, over time, black holes evaporate. They shrink, they die, and with them, it seemed, so does everything they consumed. But this violates quantum law. If a black hole swallows a diary and later evaporates into random heat, then that diary is gone, not just destroyed, but erased from the fabric of reality. And that, quantum theory insists, is impossible. It's as if the universe burned a page and tore it from the cosmic record. A glitch, a betrayal, a paradox. This is the information paradox. It sits like a knot at the heart of modern physics, strangling the harmony between gravity and quantum mechanics. On one side, the unforgiving logic of general relativity. On the other, the sacred preservation of information. And between them, a singularity that won't yield. The question becomes, where does the information go? If it cannot escape the black hole and cannot be destroyed, it must be somewhere. But where? And how? Some physicists argue that the information is encoded in the Hawking radiation itself, that it's not random, but subtly structured, that every photon escaping the event horizon carries a whisper of what was once inside, that if you could read it all, every flicker, every burst, you could reconstruct the history of what the black hole devoured. But others point out that the radiation appears thermal, chaotic, unmarked. Trying to recover the past from it is like trying to reconstruct a symphony from the sound of waves hitting a cliff. Another theory proposes that the information never really enters the black hole at all, that it's preserved on the event horizon, a holographic shell encoding everything that falls inside, like a cosmic ledger. This idea, called the holographic principle, suggests that our three-dimensional universe may be a projection of information stored on a two-dimensional boundary. That reality itself is a kind of illusion, not less real, but more mathematically elegant than we imagined. And still others argue that black holes may not evaporate completely, that something remains at the end, a remnant, infinitesimal, yet infinite in memory, forever clutching the past. But beneath the mathematics, beneath the metaphors and theoretical models, lies a deeper tension, one that isn't about particles or space-time, but about memory, about loss. Because the information paradox isn't just about what the universe remembers. It's about what we remember, about the fear that the things we love, the lives we've built, the the names we've spoken, might vanish into some gravitational silence, that there could be places where the past is not just unreachable, but untraceable, and that even the cosmos, vast and all-seeing, might forget. But maybe that fear is premature. Maybe the paradox is not a crisis, but a clue, that the universe is stranger and more interconnected than we know. That information, like love, like pain, like memory, cannot be truly lost. It can fade, yes. It can blur, it can disappear from sight. But it remains, woven into the trembling fabric of existence, waiting to be found, or reassembled, or rewritten. Perhaps every particle that falls into a black hole is not a death, but a question, asked not in words but in equations, a question that forces us to rethink what it means to exist, to record, to matter. If the universe refuses to forget, then maybe there's hope for all of us. For the things we fear are lost, for the names we no longer speak aloud. So the next time you see a photo burn, or a star collapse, or a truth unravel, remember this. The information may be gone from view, but it is not erased. It echoes. It curls itself into the margins of reality. It becomes something else. And if we look carefully enough, not just with instruments, but with imagination, we might find that nothing is ever truly lost. Not even us. Chapter 13. The Paradox of the Ravens. When green apples prove black birds. A raven sits on a fence post, black feathers, sharp beak, watching you with eyes that seem to know more than they let on. You write in your notebook, "This raven is black." Later, another flies past, same color, then another, and another, all black. You begin to form a hypothesis, casually at first, then with growing confidence. All ravens are black. It's a simple statement, a universal generalization, and like all such claims, it's rooted in observation. You see something repeatedly, and your brain begins to build a rule. But here comes the twist, the unraveling, the paradox with feathers. Suppose you walk into a grocery store and pick up a green apple. Does this, in any way, support your belief that all ravens are black? Logic says, yes. And that's the problem. This is Hempel's paradox, also known as the paradox of the ravens, and it begins innocently enough, with a principle so fundamental we barely notice it. The principle of confirmation. It says, if a statement is true, then any observation that is logically consistent with it supports it. So if the statement, all ravens are black, is logically equivalent to all non-black things are non-ravens, then observing a green apple, a non-black thing that is not a raven, is technically a confirmation of your hypothesis. That's where the stomach twists. Because while it might logically make sense, it feels absurd. You didn't observe a raven. You weren't even near one. You were holding fruit. How can that confirm anything about birds, especially ones you didn't see? And yet, deductively, the equivalence holds. All ravens are black, and all non-black things are not ravens, are just mirror images of the same logical structure. But psychologically, experientially, they aren't equal at all. You can observe 1,000,000 non-black things that are not ravens, carrots, clouds, snowmen, seafoam, and still know nothing more about ravens themselves. This is the core tension, the difference between logical confirmation and informational relevance. Let's push deeper. Suppose you're a scientist cataloging the world. You begin collecting instances that support your theory, black ravens. Each one, you believe, adds weight to your claim. But what about white doves, brown dogs, green apples? The list of non-black, non-ravens is infinite, and most of it feels entirely irrelevant. Should we really count each of them as supporting evidence? The paradox reveals something unsettling, that logic, in its rawest form, doesn't care about meaning. It sees only structure. It tells you that every object not disproving your theory is technically supporting it, even if it feels like nonsense, even if it tells you nothing new. So where does that leave us? Are we wrong to trust intuition? Or is logic itself too blind to guide us? Maybe both, because this paradox is a mirror, not for the birds, but for the mind. It shows how we crave patterns, how we desperately seek certainty in the face of vast unknowns. We form generalizations, not just from what we see, but from how we frame what we see. Our brains filter for meaning, not just structure. And sometimes that filtering creates a gap between what is logically valid and what is psychologically useful. In other words, we're not pure logicians, we're meaning makers. This isn't just about ravens, it's about belief, about how we confirm the stories we tell ourselves. We say, all success comes from hard work, and point to the successful. But what of those who worked just as hard and failed? We say, this always happens to me, and count every time it does, ignoring the instances when it didn't. Our minds, like the paradox, are selective. We gather ravens, we ignore apples, and yet the green apple does matter, not because it tells us about ravens, but because it shows us the limits of confirmation itself. It reminds us that evidence isn't just about stacking observations, it's about context, relevance, expectation. 1,000,000 confirming instances won't prove a rule. A single counterexample, a white raven, will destroy it. And maybe that's the final twist. This isn't really about how to confirm a hypothesis. It's about how fragile certainty is, how easily it's shaken when logic pulls one way and experience another, and how often our deepest convictions are built not on evidence, but on the illusion of evidence, on the ravens we remember and the apples we forget. So the next time you reach for a piece of fruit or a conclusion, ask yourself what you're really confirming. Are you proving the rule, or just feeding the story you already believe? And if someone showed you a white raven, would you change your mind? Or would you just say, that's not a real raven? Chapter 14. The Unexpected, Hanging Paradox. The Execution That Couldn't Happen. A prisoner sits alone in his cell. He has 7 days left. On Monday morning, the judge visits and delivers a strange, chilling sentence. You'll be hanged at noon on one weekday next week. But it will be a surprise. You will not know the day of the hanging until the executioner arrives. The door slams. The silence thickens, and the paradox begins. The prisoner, being a thoughtful man, a logician perhaps, begins to reason. If I haven't been hanged by Thursday, then the hanging must occur on Friday. But if I know that, it won't be a surprise. So Friday is eliminated. He nods to himself. If Friday's ruled out, and I haven't been hanged by Wednesday, then it must be Thursday. But I'd expect that too, so Thursday is out. One by one, he eliminates each day, all the way to Monday. It's impossible, he concludes. They cannot hang me unexpectedly. And yet, come Wednesday, just after lunch, the guards arrive. They lead him to the gallows. He weeps, not for fear, but from confusion, because, despite all logic, he is genuinely surprised. This is the unexpected hanging paradox, and it is perhaps the most unsettling of all logical puzzles, not because it twists physics or mathematics, but because it turns certainty against itself. The more you try to outsmart it, the more it slips through your fingers. The paradox hinges on the idea of self-reference. The judge's statement sets up a loop, a prediction about a future event, paired with a condition that the subject cannot foresee it. But as soon as the prisoner begins reasoning through the logic, he entangles himself in a recursive contradiction. If he can predict the hanging, it can't happen. If he can't predict it, it can. It's like trying to write a sentence that says, "This sentence is false." If it's true, it must be false. If it's false, it must be true. The statement eats itself, a logical Mobius strip. But what makes the unexpected hanging more than just a clever riddle is how human it is. It's not about ravens or Schrödinger's cat or black holes. It's about expectation, about how the mind grasps for control in a world built on uncertainty. We all do this. We forecast. We overthink. We imagine every possible outcome to brace for the worst. We try to make the unexpected expected, to soften the blow before it lands. And just like the prisoner, we find that the more we anticipate, the more we suffer from surprises that logic said shouldn't exist. In some versions of the paradox, the prisoner even writes letters to the judge, arguing that the execution is logically impossible. He's built a fortress of deduction, a wall so high no hanging could ever climb over it. But logic isn't a wall. It's a hall of mirrors. And sometimes, the thing you're trying to avoid steps out from a reflection you didn't see. Now, let's pull back, because this isn't just a curiosity. It's a parable about reasoning, about assumptions, about how our minds construct narratives that seem airtight until life kicks the door in. The prisoner's mistake wasn't his logic, it was his premise, the assumption that his logical deductions about the surprise would hold up against reality. But surprises don't follow syllogisms. Life doesn't care about neat conclusions. The paradox invites us to question our obsession with prediction. It whispers that not everything can be known in advance, that some truths can only unfold in time, not in thought. It also draws a thin, eerie line between knowledge and control. The prisoner believed that by knowing, he could neutralize the threat. But the surprise was never about the day. It was about the gap between belief and being, between understanding the rules and facing their consequence. And here's the deeper twist. Maybe the paradox only works because the prisoner is smart. Maybe the judge's real trap wasn't the hanging, but the thinking about the hanging, the psychological torment, the recursive analysis, the slow erosion of certainty. We've all been there, waiting for a phone call, a diagnosis, a decision, wondering not just what will happen, but when. And sometimes that waiting, that anticipation soaked in anxiety, is worse than the event itself. The paradox isn't the hanging, it's the expectation of the hanging. So what does this teach us? That reasoning has limits, that surprise is fundamental to experience, that not everything can be gamed, mapped, or mentally pre-lived. Some things, no matter how much you prepare, will find you unready. And maybe, just maybe, that's a feature, not a flaw. Because if life were fully predictable, fully deducible, fully transparent, it would be unbearable. Boredom is the slow death of absolute certainty. Surprise, even when cruel, is the thing that keeps the story alive. So the next time you find yourself reasoning in circles, trying to outthink fate, Remember the prisoner, sitting alone, convinced he's beaten the paradox until the door opens. And in that moment, the only truly unpredictable one, he realizes that certainty was the illusion all along. Chapter 15. Maxwell's Demon. The creature that dares to defy entropy. There's a box, sealed, silent. Inside it, gas particles dance like children at a carnival, bouncing, ricocheting, swirling with heat and randomness. The box is split down the middle into 2 chambers, and in the dividing wall, a tiny door. At first, this door means nothing. It is shut. Useless. But then, someone opens it, not by hand, but by mind, and in that moment, everything begins to unravel. The one who opens it is no ordinary being. It is a creature so small it has no mass, so clever it needs no rest, so precise it operates at the level of atoms. It sees every particle, knows every motion. It is invisible and omniscient within the box. It is called Maxwell's Demon, and it breaks the rules. Imagine this. The demon watches the particles flit about, waiting. When a fast-moving, high-energy particle approaches the door from the left, the demon opens it just briefly, allowing the particle to pass to the right chamber. When a slow, cooler particle approaches from the right, the demon opens again, sending it left. Over time, something strange happens. The right chamber grows hot. The left grows cold. A temperature gradient forms. Heat has flowed from cold to hot, without any work being done, and that's impossible, or at least it should be. According to the second law of thermodynamics, entropy, disorder, must increase. Heat spreads, not concentrates. Energy disperses. Systems become more random, not less. That's why your coffee cools, your room gets messy, your body ages. It's the reason time moves forward. Entropy is not just a concept, it's the direction of reality. But Maxwell's demon defies this. It sorts, it organizes, it creates order from chaos, and it does it without lifting a finger. This thought experiment, proposed by James Clerk Maxwell in 1867, was meant to probe the limits of thermodynamic law. But it quickly became a paradox, a puzzle that revealed how little we understand about information, energy, and the nature of time. The demon doesn't add energy. It doesn't exert force. It simply knows. It sees the particles and chooses when to open the door. That knowledge, that observation, seems to violate the sacred flow of entropy. The universe becomes less disordered because of a being that acts solely on information. And that's the heart of the paradox. Because if information can be used to reduce entropy, then information has thermodynamic power. It has weight, even without mass. It has cost, even without energy. For decades, physicists argued about this. Some tried to save the second law by saying the demon must get tired. Others said it would require energy to open and close the door. But the most elegant resolution came not from physics, but from information theory. In 1961, Rolf Landauer proposed a radical idea. The act of erasing information generates heat. It creates entropy. So when the demon resets its memory, forgets which particle was fast, which was slow, that act restores balance. Entropy is not violated. It's just shifted from motion to memory. And suddenly, the demon becomes a metaphor, not just for physics, but for us. Because we too are sorting machines. Every day, we filter reality, what to keep, what to discard. We remember some things, we erase others, and in that process, we generate a kind of cognitive heat, a cost, subtle but real. Attention is not free. Focus consumes something, and forgetting, in its own way, leaves a scar. What if every decision we make is like that tiny door? What if our minds are full of demons, choosing, moment by moment, which thoughts pass through, which emotions are stored, which dreams survive the entropy of daily life? We are not passive vessels drifting in thermodynamic winds. We are participants in the flow, sorting, always sorting. And here's the loop. The more we observe, the more we know. The more we know, the more we must forget. And that forgetting, that loss, is where entropy creeps in. It's not the particles that disorder the world, it's the limits of memory. So maybe Maxwell's demon doesn't violate the second law. Maybe it reveals it in a more personal, more haunting light. Maybe entropy isn't just about heat and motion. Maybe it's about the cost of clarity, the price of consciousness, the shadow side of insight. Because there's something beautiful and tragic about a creature that can see everything, remember everything, act perfectly, and still be bound by the laws of forgetting. There's something human in that. And maybe the paradox isn't whether the demon breaks the rules. Maybe the paradox is that even with perfect knowledge, loss is still inevitable. So the next time you feel the weight of forgetting, a name, a moment, a version of yourself, remember this: even the demon must erase. Even perfect vision has a cost, and in that cost, the universe keeps its balance. One door at a time. Chapter 16. The Paradox of the Double-Slit Experiment. The curtain that collapses when you peek. There's a screen, a blank, waiting canvas. In front of it stands a barrier, and in that barrier are two narrow slits, windows into possibility. And across from it, a particle gun, precise, deliberate, and patient. It doesn't fire a stream. It doesn't flood the world with data. It fires one particle at a time. Let's say it's an electron, small, subatomic, supposedly a particle, a thing like a marble, with weight and position and meaning. You fire the electron, it travels, it hits the screen, a dot appears, you fire another dot. You repeat, one by one, slow and careful, until a pattern begins to form. But the pattern is not what you expect. Instead of two clusters, one behind each slit, you get interference, bands, a ripple of dark and light. It looks like a wave passed through both slits, split, interfered with itself, and struck the screen as a dance of crests and troughs. But how can this be? You fired particles, not waves. You sent them through one at a time. There was no other particle to interfere with. And yet, here it is. A wave pattern. A whisper from the quantum world that particles, when unobserved, do not behave like particles at all. They behave like possibility. Now add detectors. Tiny, delicate machines placed at the slits to watch which one the electron goes through. Nothing invasive, just observation. You want to know, left slit or right? That's all. Fire again. And everything changes. The interference pattern disappears. The electrons now form two clusters, like marbles tossed through two openings. The wave vanishes. The particle reasserts itself. Simply by observing the electron's path, you've changed its behavior. It is not that the detectors blocked the wave. It is that the act of measurement collapsed the possibility. The universe, confronted by your curiosity, made a choice. And the pattern on the screen, your proof, is different now. This is the paradox of the double-slit experiment, and it may be the most disorienting experiment in all of science. It reveals that matter, the very stuff of existence, is not passive. It does not sit quietly, waiting for you to measure it. It exists in a superposition of states, a ghost cloud of probabilities, until the moment you ask it a question. And when you do, it answers by becoming something real. That's the paradox, that what is real depends on whether you looked, that particles are waves until you watch, that the very framework of reality seems to wait for a witness before deciding what it is. And this raises a question that physicists still wrestle with. What counts as observation? Is it the detector, the data collection, a conscious mind looking at the result? Could it be that awareness, the act of knowing, is what collapses the wave? Because if that's true, then consciousness isn't a byproduct of the universe. It's part of the machinery, a collaborator in the production of reality. It sounds mystical, it sounds absurd, and yet it's what the math says. Some interpretations try to rescue determinism. The many worlds view says the wave function never collapses, that every possibility happens, each in a separate universe. In one, the electron went left, in another, right. The pattern on your screen is just a slice, a single strand of a cosmic braid. You didn't collapse the wave. You selected your path through it. Others say the collapse is real, and the observer's role is sacred. That knowledge itself changes the outcome. That without a question, the universe refuses to give an answer. And still others argue that the particle was never real in the first place, that it was only ever potential, and reality is what happens when potential ends. But beyond the physics, there's a deeper lesson here, one that reaches past electrons and slits into the way we live our lives, because we too are waves. Not in the physical sense, but in the personal one. We exist as clouds of possibility, futures unchosen, selves uncollapsed, until we make a choice, until we act, until we're observed. Every day you are many versions of yourself. The brave one, the coward, the creator, the destroyer. And what collapses the wave? What defines you? A decision, a moment of awareness, a glance in the mirror, a voice saying, "This is who I am today." And just like the electron, your past becomes real only in hindsight. Maybe that's the most unsettling part of all, that the future is not just unknown, it's undefined, that what will happen isn't hiding around the corner, waiting to be revealed. It hasn't been written yet. It depends on how you look. And the universe? It's watching, too, waiting for the next particle, the next question, the next observer. So the next time you hesitate, caught between choices, left or right, leap or linger, remember this. The moment you decide, the pattern changes. The wave collapses. The world reshapes itself around your attention. And the screen, that blank screen, writes its story one dot at a time. Chapter 17. The Paradox of Free Will. The illusion that chooses itself. There's a moment, fleeting, microscopic, where you hover over a decision. To speak or stay silent, to leave or linger, to turn left or right. In that sliver of awareness, it feels like the choice is yours, utterly, absolutely. You weigh the options, you consider, and then you choose. A flick of mental muscle, a declaration of self. This, you say, is my will. But what if it isn't? What if, in that moment of choosing, you were simply acting out a script already written, a complex web of prior causes, stretching back before memory, before birth? What if the feeling of choice is not the cause of action, but its shadow? This is the paradox of free will, and it has haunted philosophers, theologians, and scientists for centuries. It is the riddle of whether we are the authors of our lives, or merely characters reading lines in a cosmic play we didn't write. Let's walk the argument. If every event has a cause, and every cause is itself the effect of a previous cause, then every action is part of a chain, a vast, unbroken sequence that began long before we were born. Your decision to get out of bed this morning wasn't spontaneous. It followed from tiredness, from responsibility, from belief systems shaped by childhood, by trauma, by caffeine, by neurons firing in patterns you never chose. Even your impulse to rebel, to prove this theory wrong by doing something random, is itself caused. You didn't summon that impulse from a void. It came from somewhere. Something sparked it, something before you, something not you. And yet, it feels like you chose. It feels like you could have done otherwise. That feeling, that intuition of freedom, is what makes the paradox so sharp. Because if determinism is true, and all actions are caused, then freedom is an illusion. But if determinism is false, and events can occur without causes, then actions are random, arbitrary, unbound from reason, which isn't freedom either. So we're left with a terrifying question. If our actions are neither determined nor chosen, what are they? Are we ghosts riding the wind, or machines pretending to dream? Some try to escape the paradox with language. They say, we are free, not from causes, but from coercion. That free will isn't about metaphysics, it's about autonomy, the ability to act in accordance with one's own desires. But this too circles back. Because where did those desires come from? Did you choose your wants, your fears, your values? Others lean into science. Neuroscience, in particular, offers a troubling clue. Studies have shown that the brain begins preparing for an action before we become aware of the decision. A readiness potential, a spike in electrical activity, precedes our conscious sense of choice by milliseconds. Not much, just enough to suggest that consciousness might be a narrator, not a driver. You move, and then your mind tells a story about why. But the paradox doesn't end there. Because if free will is an illusion, then so is responsibility, so is guilt, so is praise. How can we punish a criminal if they could not have chosen otherwise? How can we celebrate a hero if their courage was inevitable? The justice system, morality, personal growth, all are built on the idea that we are agents, that we could have done differently, that we are, in some meaningful sense, free. And yet, if we reject free will entirely, we lose something vital. Not just accountability, but hope. The belief that we can change, that we can choose a better future, that we are not locked into the same patterns, doomed to repeat our pasts like a looped recording. So what's left? Some embrace compatibilism. The idea that determinism and free will can coexist, that freedom is not the absence of causation, but the ability to act according to your own internal logic, even if that logic is itself caused. In this view, you are still a node in the causal web, but one with a unique perspective. You are the intersection of genetics, history, and experience, and that intersection has shape, and shape has agency. Others turn inward and ask, who is the you that chooses? Is it the conscious mind, that fragile narrator spinning stories in language? Or is it the subconscious, the deeper machinery of the self, where patterns are laid long before awareness flickers? And maybe that's the answer hiding in the paradox, that free will is not binary, not yes or no. It's a spectrum, a gradient between instinct and insight, between past and present, between the autopilot and the hand on the wheel. Maybe freedom isn't the absence of constraints, but the awareness of them, the ability to see the loops you are caught in, and sometimes to step sideways, even if only for a moment. So the next time you make a choice, large or small, pause, not to doubt your freedom, but to feel it, to sense the undercurrents beneath your decision, to listen for the echoes of what led you here. And if you hear the whisper of a chain, cause linked to cause, stretching back through time, don't despair. Because maybe the paradox doesn't mean we aren't free. Maybe it just means that freedom was a miracle, one that happens inside the very system that says it's impossible. Chapter 18. The Paradox of the Liar. The truth that destroys itself. This statement is false. 6 words, plain, honest-looking, like a riddle whispered by a child or printed in small font on the back of a cereal box. At first glance, it barely raises a pulse, but stare long enough, and it becomes a black hole, one that pulls language, logic, and even truth itself into its orbit and swallows them whole. Because if the sentence is true, then what it says, that it's false, must be the case. But if it's false, then what it says isn't true, which means it must be true. And so the loop begins. Back and forth. True, then false. False, then true. A coin flipping in midair, refusing to land. It is the simplest of paradoxes, and perhaps the most devastating, because it doesn't twist physics or bend time. It turns reality against itself. This is the liar paradox, and it's older than most religions, more persistent than most empires. It was first recorded over 2,000 years ago, attributed to Epimenides, a Cretan who famously declared, "All Cretans are liars." If he's telling the truth, he's lying. If he's lying, he's telling the truth. It's a linguistic Ouroboros, a statement that eats its own tail. At first, it might seem like a clever word game, the kind of thing philosophers use to pass time or impress students. But the deeper you follow it, the more fundamental the problem becomes. Because the liar paradox doesn't just reveal a glitch in syntax, it reveals something terrifying. The truth can collapse under self-reference. Try to build a logical system. Lay down rules, definitions, a clean hierarchy of statements and values. Now allow just a single sentence to refer to itself, to point inward like a snake biting its tail, and the system begins to tremble. You've introduced instability. You've opened the door to contradiction. In the early 20th century, this wasn't just a game, it was a crisis. Mathematicians were trying to build a solid foundation for logic itself, a complete, consistent framework where every truth could be proven, every contradiction weeded out. But then came paradoxes like this, and everything started to shake. Bertrand Russell tried to formalize the problem. If you define a set of all sets that do not contain themselves, does that set contain itself? If it does, it shouldn't. If it doesn't, it must. A cousin of the liar, dressed in formal wear. Gödel took it further. In his incompleteness theorems, he showed that any sufficiently powerful system will contain statements that are true but unprovable. Self-referential riddles that cannot be resolved from within the system itself. And there it was, a limit. Not of knowledge, but of knowability. Not of language, but of what language can do. The liar paradox stands like a mirror at the edge of reason. It doesn't lie. It doesn't tell the truth. It simply refuses to play the game by which we understand reality. It whispers that maybe not everything can be named, that maybe truth is not an absolute, but a dance, sometimes circular, sometimes chaotic, sometimes beautifully incomplete. Let's pause here, because this isn't just philosophy, it's personal. We are, in many ways, walking paradoxes. We want honesty, but we lie. We want meaning, but we doubt. We say, I always lie, with a grin, not realizing the recursive hell we're stepping into. We write stories about liars who tell the truth and truth-tellers who lie. We crave contradiction in our fiction, our politics, even our identities. Think about how often we say things like, I know nothing, or I'm the kind of person who's impossible to describe. These are liar paradox statements, beautiful, messy collisions between self and language. We use them not because we want to break logic, but because we live at its edge. And maybe that's the real message of the liar paradox. That language, for all its elegance, is not built to capture the full scope of consciousness. That truth, once it loops back on itself, becomes a flickering candle, impossible to pin down, but essential to the dark. So where does this leave us? Some have tried to solve the paradox with layers, levels of language, hierarchies that prevent a sentence from referring to itself directly. Others say the statement is meaningless, that it breaks the rules, like dividing by zero. But none of these feel satisfying, because the paradox isn't a bug, it's a signal. It shows us where the edges of logic are, where maps end and reality begins, where the tidy boxes of truth and falsehood crack under the weight of self-awareness. Because to say, this statement is false, is not just to twist grammar. It is to mimic consciousness itself, a thing that knows itself, sees itself, and contradicts itself in every breath. We say we want truth, but we live in stories. We say we want certainty, but we thrive in ambiguity. We say we are rational beings, but our most fundamental ideas unravel when they look in the mirror. So the next time you find yourself caught in a contradiction, loving someone you shouldn't, fearing something you know can't happen, saying something you don't fully believe, remember the liar. It's not a flaw in logic. It's a window into what it means to be alive. Chapter 19. The Tele-transportation Paradox. The death that thinks it's you, step into the chamber. The doors slide shut behind you, with a hiss that sounds more like a decision than a sound. You're calm, mostly. You've read the brochure, signed the waiver, watched the testimonials. The technology is flawless. Decades of tests, billions of successful transports. Everyone says the same thing. It's safe, it's seamless, you won't feel a thing. And they're right, because what you're about to do is disappear. The teletransporter works like this. It scans your body, every atom, every molecule, every quark, and records your structure with subatomic precision. Then it destroys you, disassembles your body down to dust, not in pain, not in horror, just quiet erasure. Gone in an instant. Meanwhile, on Mars or the Moon or Tokyo, wherever you're headed, a second machine receives the signal. It reassembles you from local materials. The copy steps out of the chamber, stretches, smiles. It remembers entering the chamber. It remembers your childhood, your dreams, your sense of humor, your allergies. It is you, isn't it? This is the Tele-transportation Paradox, and it doesn't need science fiction to haunt you. It just needs a question. Is that person on the other side really you? Because if the original was destroyed, if the atoms that made up your brain are now ash, then something was lost. even if the copy is perfect, even if they're indistinguishable, even if they're standing in front of your friends saying, "I'm back," with your voice. Is that survival, or is it replacement? Here's the twist. The copy doesn't know the difference. It has your memories. It remembers stepping into the chamber. It feels continuous. But from your perspective, the one standing in the chamber, do you wake up on Mars, or do you never wake up again? Because if consciousness is a product of physical structure, then sure, recreate the structure, recreate the mind. But if it's more than that, if there's something ineffable, uncopyable, something tied not just to the pattern, but to the matter, then the you who stepped into that chamber never made it out, and the you who steps out is just a story, a continuation that doesn't include you. Let's press this further. Suppose you could make 2 copies. You step in and 2 yous step out, one on Mars, one in Paris. Both feel real. Both remember your life. Both love your dog. But they are now diverging. New experiences, new paths. One orders espresso, the other green tea. They are no longer the same. So which is you? And now rewind. Suppose the original isn't destroyed. You're copied, and both versions live. The original you is sitting in a cafe. The copy you is walking under Martian stars. Which one is the real continuation? Do you share a soul? Does that word even mean anything now? The paradox doesn't lie in the machine. The machine works. It lies in our idea of self, because we like to think of identity as a continuous line, a thread pulled from birth to death. But what if it's not a thread? What if it's a pattern, a shape that can be copied, cloned, restarted? What if you're just information? It feels wrong, cold, inhuman. But look closer. You already change every day. Cells die. Memories fade. You are not the same person you were a decade ago. Not chemically, not psychologically. And yet, you still call yourself me. Why? Because the story continued. Continuity is the illusion we build around change. It's the comfort we paint over loss. The teletransporter doesn't break the self. It exposes its fragility. Some say, if the copy is perfect and the original is gone, then the self has survived. Because selfhood is experience, not material. Others say, no, because consciousness is not like software. You can't move it. You can only recreate it. And what you recreate is not you. It's a mimic, a ghost, a reflection. But here's the deeper horror. You'll never know. Because the only person who can answer the question is the one who didn't survive. And maybe you've already experienced it. Every night when you sleep, when consciousness fades, are you the same person who wakes up? Or just a copy with yesterday's thoughts? You feel continuous? But can you prove it? Can you ever? That's the paradox. Subjective continuity feels real, but it's untestable. And that means we might already be copies, living in a chain of selves that replace each other daily, hourly, breath by breath. So what do we do with this? Some say, don't use the teletransporter. Others say, embrace it. Let go of the illusion of a permanent self. Accept that identity is just a river, no molecule staying in place, yet somehow always the same. But maybe the truth is this. We are not the original or the copy. We are the transition, the moment of being between scanning and reassembly, between breath and breath, between today and tomorrow. You are not the chamber. You are the choice to step inside. And if the copy steps out and looks at the stars and says, I am alive, then maybe that's enough. even if you're not there to hear it.